Okay, friends, good evening. So, in the last session, I'll discuss very briefly the emerging areas of research in mechanical engineering. Uh, as you know, research we carry out primarily based on the needs of the present and the needs of the future. So, if we look at the needs of the human race, presently one problem with us is we have a growing population, and therefore we need the management of resources which are limited. Some are practically unlimited also. Then we want to provide a better quality of life to the people, especially to the elderly and differently abled or maybe injured people or sick people. And then we want continued development of electronic communications and the modes of travel. There may be some more. I have listed some. So based on these, if we consider the cutting edge areas, so some of the cutting edge areas are given here in the form of a plot. The source is latest document of American Society of Mechanical Engineers, in which the energy has been listed as the most important area for research. Then next is bioengineering and biomedical engineering. Then nanotechnology, alternative energy, water, and so on. Right. So as we said that because our planet is being loaded with more and more population, so energy is a very important issue. Then for providing quality life, bioengineering and biomedical is critical. Then nanotechnology, both from a biomedical point of view as well as other engineering requirements. Alternative energy sources like sun, wind, etc. Then water, computers, electronics, clean energy, environmental, renewable energy, material science, sustainability, robotics, communications, chemical engineering, and information technology. So mainly in the field of mechanical engineering, some emerging and enduring areas of research that we have are listed here. So first is precision manufacturing. Precision manufacturing is required nowadays because we want the components to have a long life and we want the components to be miniaturized. Right? Now there are very small robots which can go into our bloodstreams, attack a particular cancerous cells, kill them, or deliver the medicine to particular areas of our body. So precision manufacturing is a very hot area of research. Now, concerned with precision manufacturing is micro machining. So when we say micro machining, that means we are talking about micron level. So we want devices which are of the size of microns, maybe comparable, a turbine, for example, a turbine which is comparable to the size of an ant. A turbine which can deliver power in terms of microwatt or even less than that. So they are required for our miniaturized robots. They are required for very precise manufacturing. So in micro machining, the issue is that how to achieve micro cuts or how to remove material at micro level. Right? So nowadays we have equipments which are being developed and manufactured and available in the market, although they are still limited, using laser technology, using some spark erosion, using some very precise methods by which we can remove layers atom by atom. Then we have hard machining. Right? So hard machining is that now new materials are coming up. For example, ceramics, which have been there for a very long time, but still now they are being used more as compared to metals. So machining a hard material is always very difficult because you can't cut it and then have good surface finish, or you can't cut it with the economical means. Surface engineering. So if we need hard surfaces, we need good surfaces, then we need to treat the surfaces so that we can get required quality or characteristics of that surface. Now, concerned with hard machining and surface engineering is tool life. So we require specialized tools, and specialized tools are expensive. So if we are going to use something expensive, we would like it to have a long life. So research in the areas of tool life is again, which is a hot thing these days. In terms of tool life, we need to have, say, coatings applied on the tools so that we can improve not only the life of the tool, but also get better surfaces of the components that we machine with these tools. So related to the first 5 items that I have listed, a very important part is developing materials. Materials for components, materials for tools. So developing new material in terms of composites, in terms of alloys, is another very, you can say, recent area. In fact, nowadays, if you look at the advertisements for researchers or faculty worldwide, especially in North America, you will find that their first choice is a person having experience in material science. Then next, a very relevant area is modeling and simulation. Just like Dr. Mehra was talking of simulation, so it's so important. Like Dr. Mehra was talking of different topics like convolution, correlation, transformation, signal processing. So all these topics are not limited to only electronics or electrical or computer science nowadays. In mechanical engineering, these topics are very much required, and a lot of research is carried out in the area of signal processing, which I'll come to. But related to that is modeling and simulation. So here I have listed 2 very important parts: thermal and fluid flow simulation and vehicle dynamics and control. So when we say vehicle, doesn't mean cars only. It can be any vehicle of any type, maybe a road transport vehicle or a spacecraft or an aeroplane or a train. Now, thermal and fluid flow. If we look at it, looks like something related to mechanical only, but all our electrical equipment, our electronic equipment, as they become small, they generate more heat. So an efficient cooling of these systems is required. Recently, our institute is lucky enough that we are a selected few with which ABB India has signed an agreement under which they are giving us around 1.65 crore rupees to set up a simulation lab. Now that simulation lab will pertain to modeling and simulating electrical equipment, for example, switches, transformers, contactors, etc. And to some extent, motors also. Now, what do they want in that is, they want not only the electromagnetic simulation of these devices, but also their thermal simulation, that how can we cool them better, their structural simulation, how can we make the air or other cooling medium flow through them in an efficient way so that their cooling is done in an appropriate manner. Similarly, vehicle dynamics and control. So we have now focus on vehicles which are, say, lighter, which are faster, which are safer. So for that, to make light vehicles, we again need new materials, and then these vehicles should also consume lesser energy. So making them lightweight is one aspect. Second aspect is making them aerodynamic. So again, fluid mechanics, fluid dynamics, thermodynamics becomes very important in their simulation. Then their otherwise mechanical dynamics, for example, what the force they are subjected to, how much do they vibrate, and how we can control them. So all the automobile companies these days, they use lot of simulation tools, specifically in the field of mechanical engineering. They very widespread. They use MATLAB and other softwares to simulate the mechanical systems. Another thing in vehicles is, for example, recently, I think up to next week, DST has invited some projects which relate to developing electric vehicles. So in electrical vehicles now, what are there? They have 4-5 areas of focus. So what are the areas? One is again the making the vehicle lightweight and more aerodynamic, and then making the vehicle consume less energy. So making it lightweight and aerodynamic will naturally lead to consuming it less energy. But when you are going to make a vehicle lightweight, we are talking of electric vehicle specifically. So that project is about electric vehicle. So we not only need to use lighter and stronger materials, but also batteries is a very main thing to consider in electric vehicles, because batteries are quite heavy. So again, one component there is to have alternative type of batteries which are lighter, which can store more energy for a longer duration of time. So to develop new batteries, to develop new motors, then apart from that, there are a few more other things. Yeah, crash worthiness. So crash worthiness is also required. So all this, before we can do experimentation, modeling is very important. So I emphasize, especially for mechanical engineering people, that they must learn to employ the mathematical models, and then to develop the virtual models, computer-based models, maybe using MATLAB, maybe using some CAD software, using finite element analysis software, like that. So it's a good area of research. Then we have sensing, which is very important. Nowadays, when we say sensors, it's not only pressure measurement, temperature measurement, but there are so many things which we need to measure. Right? Sensing is now all the more critical because, as you know, now we have the Internet of Things, IoT, which people call. So IoT is doesn't only relate to electronics or computer science. In fact, it is so much closely related to mechanical engineering that a consortium of German government and German companies, in 2011, they came up with a new term called Industry Standard 4. So what is this Industry Standard 4 is? That they say it is the fourth revolution in manufacturing that has come. The first revolution was when the steam engine was developed. Second revolution was when the electricity was invented. Third revolution was when electronics, miniaturized, and automation became very widespread in manufacturing industry. And now the fourth is the advent of information technology, where internet is there, all the devices are connected. So from mechanical engineering point of view, so now they foresee that in future industries, many present day concepts like ERP, they will become obsolete, because it will be the machines which will know what to make, how much to make, how much inventory is available in store. So machines will automatically order whenever they find that the inventory in the store is low, or whenever they find that there is something wrong going to happen with them. So IoT is coming in a big thing, and a main thing in IoT is sensors. Because in IoT, we will need sensors, again, which are very small, lightweight, quick to respond, have a long battery life, like that. And then we may be requiring to sense things which so far maybe we have not sensed. But even otherwise, even something conventional things that we think of to be very, very simple, they are also very important. For example, piping. So piping is going to play, now also it plays a very important role. So avoiding leakage in pipe is still today, as on date, a very, very hot topic of research worldwide. Then lastly, we come to condition monitoring. So again, condition monitoring sensing is there, uh, involving signal processing, so that from the data that is given by the sensors to the controllers, they can process the data and find out that whether any uh, defect is going to occur in the machine. So these are some hot areas of research in mechanical engineering. Uh, Okay, this I will just skip. This slide only says that some people were interviewed and asked that how will you acquire knowledge for different research areas. So self-study was the most, uh, say, it got the maximum number of votes. Most people said they will go in for self-study, and the sources are all their websites, magazines, books, like that. Now, what are the tools and techniques? So if we divide the tools and techniques into two parts, one is emerging, one is enduring. Emerging is virtual prototyping, so which is a very big thing in, say, research and development. Like in India, we have, say, our institute has one RPT machine, but if you go to Singapore in colleges, they have a line of small virtual prototyping machines in different labs, cheap ones also. And even in USA, they have a concept of maker space or maker lodge, where not only colleges but cities also provide some space to the people of the town, where all the type of conventional tools, design CAD tools, and RPT machines are available for people to just play and explore their ideas. And then motion simulation and animation. And then enduring tools are, of course, CAD software, which has been long, computational fluid dynamics, finite element analysis, statistical analysis, and coding. Coding is now very, very important. Without computer programming, I don't think research is possible in any field. So I will just, because we have running short of time, so I'll just quickly go through some of the facilities which are available in our institute. We have a variety of CAD/CAM software available with us, which relates to developing CAD models and then their analysis. Some specific softwares also we have, like SimuEffect, which is for forming and forging operations, simulation of forming and forging operations. CaseSoft, which is for designing gears. Then we have specific CAD workstations, like they are expensive, but they are suitable for CAD software. Then we have a 3D scanner. So you just put a component on this, and then there is a set of two cameras which will scan the component. The table will rotate, the table, the cameras, everything is synchronized, and it will develop a cloud of data points using which we can build the CAD model. We don't have to actually make a CAD model manually, it's all automated. Then a simpler thing as compared to 3D scanner is a machine vision system. Again, here it's all based on image processing, and all the latest image processing techniques are used. So you just keep a component on the platform, the camera will scan it and generate a CAD model of this. Then the rapid prototyping machine. So the machine which we have is, we can make components from using ABS polymer material, but nowadays metal RPT machines are available, although very expensive, starting from 2.5 crores. So academic institutions can't afford that much, but many industries, even in India, have bought these machines. Then related to manufacturing is material characterization. So we have a spectrometer. So you just keep a small piece of alloy in the machine. It will tell you what are the components. It hardly takes a few minutes to tell what are the different contents of the alloy. For example, how much is ferrous there, how much carbon, how much chromium, tungsten, vanadium, so on and so forth. Then, as during discussion on topics, we said that tool life. So coating is very important concept. A very cheap alternative to coating as compared to physical vapor deposition or chemical vapor deposition is a potentiostat. So it costs around 10 I think even less than 10 lakhs or so, but we can apply coatings on the tools and do experimentation and research. Then for testing the hardness of the coatings, we have micro hardness tester, and also we have not shown here, a scratch tester, which determines what is the extent of adhesiveness of the coating onto the substrate. Then for manufacturing, we have a CNC vertical milling center, and we also have a spark erosion electric discharge machining. Now during machining, to improve the efficiency of machining, a very important concept is measuring the vibrations and the thermal behavior. So for that, we have recently purchased a thermal imaging camera. It costs around 4.5 lakhs or so. So it's very efficient system and can detect a wide range of temperature. So it can simply take a view and then tell, okay, how much temperature is at which location, similar to the night vision devices that our defense uses. Then we have a scanning electron microscope. So after a component is manufactured, to characterize its surface, we have the SEM along with EDX. EDX will also tell how much what is the composition of the surface. Again, surface roughness tester, because surface roughness is a very important characteristic of the machine component. Then to detect internal flaws, we have ultrasonic flaw detector, which comes under the category of non-destructive testing. Then in condition monitoring, we have setups for gear shaft bearing condition monitoring. We also have some sensors, a setup for studying the behavior of sensors which are used in automobiles. So these are the overall equipment that we have. And these are some research titles that have been of PhD level, which have been completed or which are currently going on. So you can go through them. For example, we have investigation of parameters for surface modification of dyes using EDM process. So here, rather than using EDM to remove the material, EDM was used to modify add the material to the dyes to modify their surfaces. Then studies on metal forming for improved surface finish. Then an experimental study of non-traditional machining of aluminum silicon carbide metal matrix composites. Then performance optimization of cutting tools with multiple nano coatings. Development and evaluation of flexible machine controller for electric discharge machining process. Study of thermohydrodynamic performance of multiple axial groove journal bearings. Development and performance analysis of a position control system for tool manipulator. Development of performance matrices for reconfigurable manufacturing systems. Techno-economic analysis of manufacturing titanium 6 aluminum 4 vanadium alloy. Experimental investigation of enhancing tool life in compacted graphite iron machining. Development of optimized design system in press work. Condition monitoring of gear behavior in electromechanical equipment. Studies on gear performance with nano-coated materials. Design and development of a real-time condition monitoring system for bearings. And synthesis and performance evaluation of a robust controller for a multi-section steam turbines. So nowadays, if we talk of mechanical engineering, the area is wide open, but broadly, you can see these topics, they also correlate with the list that I had given in the beginning. So I'll stop here, madam. So if there are any questions, please.